Hello, and welcome to Section 4, Wire Up the UI. This is the first video in this section, and this is where we'll learn about Android's data binding library, as well as enable our app FieldFinder to start using data binding. So let's begin. Android's data binding library is a support library, so it works all the way back down to Android version 4.0 or Ice Cream. It's part of the Android architecture library, or architecture component library, along with room persistence library that we used in the previous section. And it also includes live data, view model, work manager, as well as a few others that we won't be covering in this course. The Android architecture component library is also part of Jetpack, which is a very nice initiative for building applications that are modern, fast, and use common development practices. With the data binding library, you actually can declare your layouts as well as the binding inside of the actual layout file. So you don't have to go inside of your activity code or fragment code and use find view by ID calls they manually call set text or different things, or manually set listeners on the object. You can do this all declaratively inside of your layout file. And this is actually very powerful and allows you to compartmentalize your code and have very maintainable files. Using binding expressions, the binding library actually allows you to assign values to your view. So as I mentioned, you don't have to call set text, but this doesn't only apply to set text, this applies to several other different values inside of your views. In addition to setting values, you can actually set listeners and create dynamic listeners that'll fire based off events emitted by the view. When using data binding in your layout files, you actually need to tweak them a little bit. It's not a traditional file. You have to have, as the root element of your layout file, a layout element. And then this layout element must have two children. First is a data element, and the second is the view element. Now let's explain the data element. The data element is actually where you'll declare any variables that you're going to reference through data binding inside of your layout or your actual view code. And then the view element is actually where you'll put your layout files and your layout code and everything, such as linear layout, constraint layout, and everything like that. And it should be the parent. So if you are converting an existing layout, your current root would now be where the view would be inside of a layout element. So it's actually pretty simple. You just simply wrap your existing layout file, add a data child, and you're done. Now, here's an example right here using the data binding expression language. The expression language allows you to write inline data bindings pretty much using this following syntax, which is the @ symbol and two curly braces. Here's an example of an image view having an image set using the data binding language or the binding language. Here's a more elaborate example showing you the actual layout tags, as well as a data tag and a variable called title, which is of type string. And when you create these variables, you have to actually specify the type, and this allows the data binding compiler to validate your expressions to make sure they make sense. And here you see us using the title to set the text on a text view. And this is actually powerful in the sense that if title were to be null, this layout would still build and you wouldn't crash. The data binding would automatically set the text value to be null. This is a list of valid operators and expressions and keywords you can use with data binding. Concatenate two strings or add or subtract or divide any type of integer value. You can use logical values, double ampersands, or double pipe symbols to do an or. You can use binary, urinary, you can shift, you can do comparisons, you can do ternary operators. And what's actually very nifty, you can access collections using array notation like you can in other languages such as JavaScript. So if you had a list, you could actually use two brackets to index inside of it. You can do the same thing with maps. So instead of calling get with a map object, you just use the two brackets and pass in the key. Furthermore, with expression language, you can also call methods and access properties on object. You can also perform casts, which is very useful. And by default, if you're passing in an argument using data binding, that you're passing in an object to a method that takes a typed argument, data binding will automatically cast this to the correct type. But be careful because data binding won't prevent any class cast exception. By default, when you set a value on an attribute in a view, the binding library will automatically look for a setter for that attribute. If you like to customize what method gets called, you can create a binding adapter. And what this allows you to do is register a method for a view that automatically will get fired when you set a value on an appropriate attribute. Also, you can customize the behavior inside of this binding. For example, you can have a binding adapter for an image view that when you set a resource, it'll automatically load that, whether from the file system or the network, asynchronously. And once it completes, you can have it set on the image view. Or you can also set several properties on the image view based off of some type of an object or value. And you don't have to write very complex binding statements. You just write a binding adapter, and then inside of this binding adapter method, it'll perform all of those actions. Reciprocally, there's also an inverse binding adapter, and you would use this for two-way binding. So when an event arises for a value, automatically this inverse binding adapter will be called and it'll retrieve the data from the view and apply it to the value. So you could actually use this value that the view is updated. Here's an example of a custom binding adapter I wrote for setting the alpha on an image view, and is actually aware of API level. So for versions above Jelly Bean, it'll use set image alpha. In versions below that, it'll use set alpha, which has been deprecated. And up here where it says binding adapter, this is simply the attribute that you'll use inside of the layout code to actually fire this binding adapter. And it simply is a static method that takes a reference to an image view and an integer. And that's all you have to do, and the binding library will automatically pick this up for you. The binding class. Now this is where the real magic starts. This binding class is created for every layout inside of your application that uses data binding. Its name will reflect the name of the actual layout file with all underscores removed in Pascal case and have binding suffix to the end of it. So for example, the sign-in activity, its layout file is called activity_sign_in. The corresponding binding class would be activity sign-in binding. Now, this binding class actually contains references for all the views with resource IDs, and internally it'll have private ones for the views without the resource IDs that you can't access, as well as a getter and setter for every method defined inside of your layout file with the appropriate type that reflects the types inside of the layout file. This binding class also contains all of the logic for updating the views based off of the changes inside of the values. Now this binding class should be instantiated by activities or fragments or any of your layout code where you would previously call find view by ID. You create this file, then you would set the data on it, and then behind the scenes this binding class will automatically update all of your views to reflect these values. To get started is actually pretty simple. The data binding library, being part of the support library, works all the way back to Android 4.0. And it works with the Android plugin version as low as 1.5.0. Now, to actually enable it in your application, you open up the application module, then find the Android block, then add a data binding block with enabled equal to true. There's actually some support inside of the Android Studio. Right now, the syntax highlighting, syntax errors for invalid expressions, which is very powerful, XML code completion, limited support in my opinion. I do find errors in it. There's references, code navigation, and quick documentation for data binding. Lastly, in the preview pane, you can actually see a default value for your data binding expressions, because by default, the compiler can't render the values that you reference inside of your XML code through data binding. So you can provide a default value and it'll show up in the preview pane. So for example, here with the text view that references the station name field on a VM object, the default value will be Sunoco when you're viewing in the preview pane. But when you're running the code actually on a live device, if VM is not null, it'll use the station name value. With Android Gradle plugin version 3.1.0 Alpha 6, a new data binding compiler was added. This new compiler will actually incrementally build your data binding classes instead of waiting to compile the rest of your managed code. This has the benefit of speeding it up because they happen in two separate steps that are unrelated, and it'll also fix some common errors you'll get with the current compiler. Now with the current compiler, it'll actually compile your managed code and then the data binding code. So if you have any errors in your managed code or your Java code, it'll stop the build immediately, and data binding library will say you have several errors or you have invalid data binding, when in fact you don't. It's just because it didn't complete its build process, it's indicating there are errors. With that being said, if you want to enable this inside your Gradle.properties file, just add the line android.databinding.enable v2 equals true. I won't be doing this for the fuel finder, but if you want to do it, you can, but it's up to you, and it is experimental as of right now. Consult the data binding documentation on the Android developer site for any behavior changes with this new compiler. So why use the data binding library? Well, I say simply because it eliminates boilerplate binding code that will litter up your fragments or activities, code that you don't need to write. The data binding library is easy to use and free. Not to mention, it also plays nicely with Android architecture components such as live data and view models, which are incredibly powerful concepts, especially when building an app for first time. Not to mention, it has speed gains. That costly method find view by ID, the compiled code can actually quickly bind your views and return that much faster for you, shaving off those little bit of milliseconds to make your application that much faster. So, without further ado, let's actually enable data binding in Fuel Finder. First thing we want to do is open up our build.gradle file for our app. And then all we need to do, inside of our Android block right here, create a data binding block. Set enabled equal to true. Then just sync now, let this finish building, and then we'll have data binding inside of our application. Can't ask for much more than that. Open up the build folder to see how it's going. Wait for this to complete, and now it's completed successfully. And let's open up the sign-in activity just to see that we can reference these. The new layout tag. Text. Give us a moment. Up here. Layout. See if we can reference the data one. Yep, we can. Variable. And that's all we need to know. Everything works. Due to time constraints, I wasn't able to cover all features and functionalities of the Android data binding library. So if you have any other additional questions or found that the information I have wasn't in-depth enough, I recommend you viewing the Android developer documentation for the data binding library. It's very thorough and has tons of examples that you can use in your own application. But everything I've covered here should give us a good starting point for using it inside of the Fuel Finder application.